In this lesson, you're going to learn how to graph quadratic functions. Recall previously we looked at three forms of quadratics. What makes a function quadratic is the fact that it has an x to the second power as its highest degree. The graph of a quadratic forms a parabola. If you recall what controls whether the parabola opens upward or downward, it is your a value. So if a is positive, you got this happy smiley face, okay? Whereas if a is negative person, they're frowning. Your parabola is going to open upside down. And that's for all three forms of a parabola. Remember that the vertex is either your maximum or your minimum point. It's the point where the curve changes direction. Y-intercept is where it crosses the y-axis. Your x-intercepts are also known as zeros. In this problem, the x-intercepts would be -1, 0, and 3, 0. Remember that a synonym for x-intercepts would be your zeros. Just often we write the zeros a little differently. We would just say that x equals -1 or x equals +3. That's just something that will help you when you switch to GMM. If you're getting an error message, that's the format you need to enter it. Your axis of symmetry is the point at which if I folded this parabola in half, it would fold on this vertical line. So an axis of symmetry is always x equals the x-coordinate of the vertex. And hopefully remember that you find the x-coordinate of the vertex by doing -b/2a. So let's look at what we call the parent function, the most basic quadratic function. And what I'm going to do is I'm going to pick some negative values and some positive values, and let's observe the symmetry that we would get. So if I square -2, I get +4. -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Notice the symmetry in the y values that's occurring here. So if I graph these points, I get the following. Notice the parabola opens upward. Okay. The vertex is 0, 0. The axis of symmetry would be the vertical line right through our vertex, so it would be x equals 0. So notice for this first point, it's 1 unit away from the axis of symmetry, so I got to have one unit away over here. If I have one 2 units away, I got to have one 2 units away over here. The domain of my parabola is all real numbers because it goes forever to the left and forever to the right. The range, however, is a little different. It would be how low to how high. Well, as I'm going up, the first value I encounter is 0, and then it goes forever upward. So that would be y is greater than or equal to 0. So all the y values bigger or equal to 0 are included. In this particular one, the x-intercept is the same as the vertex. So let's look in general at how to graph a quadratic equation or quadratic function. So first of all, I notice that a is negative, so this parabola is going to open upside down. It's going to be frowning. So what you want to do in general is always begin by finding your vertex. So you're going to do -b/2a, which would be +4/2 times -2, which is 4/-4, which equals -1. So the x-coordinate of my vertex is -1. Now how do I get my y? Well, I got to plug that into my function. So everywhere there is an x, I'm going to replace that with -1, and I get y is 3. So the vertex is going to occur at the point -1, 3. And I know it's going to open downward. So you need to find at least one other point, and then we'll use symmetry to graph the rest. So if my vertex is -1, what I do is I choose one point to the right. So I'm going to pick 0 because that's 1 unit to the right of my vertex, and I'm going to plug in 0. When I plug in 0, I get +1. So by symmetry, I know that the point that is immediately to the left of my vertex also has to have a y value of 1 because it has to be symmetrical. So immediately to the left would be -2. So I know there's a point right here because the axis of symmetry has to go through the vertex. So my axis of symmetry would be the vertical line x equals -1. And I'm going to draw my smooth curve. Now, To find my x-intercepts, we're going to do that using the graphing calculator. Domain, again, is all real numbers, and the range would be, well, this time the highest it goes right here is the y value of the vertex, which is 3, and it's all the values less than that. So it's y is less than or equal to 3. Let's look at how to find the intercepts now in the graphing calculator. To graph your quadratic, enter your function, so negative 2x squared minus 4x plus 1. Hit zoom 6 for your standard viewing window. If you do not see a good picture of your parabola, you need to take the time to adjust your viewing window. I have some excess space on the left and right, but this is not too bad. It wouldn't hurt to make it a little smaller, maybe negative 6 to positive 6 on the x, and I'll see an even wider parabola here. Now, if I hit trace, I will see the y-intercept of 0, 1. I am going to show you how to find the vertex. So to do that, you're going to do second trace, and it's going to ask you a series of 3 questions, but I suppose we need to choose which one is right. If your parabola opens downward, it has a maximum, so you're going to choose option 4. You need to be to the left of where your maximum occurs, so move your cursor to the left. So it's going to be about right in here is where the vertex will be. So I'm going to go a little bit to the left of that. I'll hit enter. Now it says right bound, so I move it to the right. So it starts to come back down the hill, enter, and now guess. Now, one of the things that it sometimes does here is it's a little bit inaccurate, 0.99999, comma 3. Well, that's just about negative 1. So what I do is I hit trace again, and I just hit negative 1, and I confirm, is negative 1, 3 a point? Yes, it is. So there's my vertex. And now I can just use the trace button to find a point to the right. I hit 0, enter. There's a point to the right. If I hit 1, enter. There's another ordered pair. Let's find our x-intercepts, because these are the other tricky things. Okay, so I can see it's not quite crossing at integer values. So second trace, I'm going to choose option 2 for the zeros. So I am going to do this process twice. I'm moving my cursor to the left of where the first 0 is. So I need to be underneath the y-axis. I can see it's negative. So I'm good. I hit enter. I need to move it to the right or above the x-axis. I hit enter. Now guess. Now, you can round for me. So the 0 is negative 2.22. As an x-intercept, just write this as an ordered pair. Let's quickly find the other one. I'm going to move my cursor over to the right, close to where that x-intercept is. So I hit second trace, 2 for the zeros, also known as x-intercepts. It says left bound. I'm going to move it close to where it occurs. I know I'm still above because my y is positive. I hit enter. I need to move it to the right till it becomes negative. I switch to negative, enter, guess. So positive 0.22. So we just saw our x-intercepts were negative 0.220 and positive 0.220. You have to be able to find your x-intercepts by hand or on a graphing calculator. By hand, you would have to let y be 0, and then you would do the quadratic formula. That's going to take a lot more time. This second or third parabola we're looking at, the a value is positive, so I know my parabola will open upward. It's in intercept form, or notice it's factored. So my zeros are going to be positive 2 and negative 4. So I'm immediately going to graph those on the x-axis. And if you remember the relationship, well, using symmetry, my vertex has to be halfway between the two. So the easiest thing to do is take these intercepts, which are 2 plus -4, and find the halfway between, which would be the average. So that would be -2 over 2 is -1. So I know that my vertex occurs at -1 comma something. How do I get what that something is? I always plug in my x to find my y. So I'm going to plug in -1. That gives me, let's see, -3 times +3, it would be -9. So my vertex is -1, -9. And of course, I didn't quite make my coordinate plane big enough to plot that vertex, but for a sketch, it'll do. I can kind of estimate where it would be. So my parabola is going to look like this. What would my axis of symmetry be? Well, it's the vertical line through my vertex, so it's x equals -1. We already stated our intercepts. They are -4, 0, and 2, 0. My domain would be all real numbers, and my range, it's going up, so it's y is greater than or equal to the y value of the vertex, -9. Again, you can completely do this on the graphing calculator. You do not have to change anything. You can type this in exactly as you see it into y equals. Just use parentheses, x minus 2 times parentheses, x plus 4. All right, let's take a look at number 4. So I see a negative a value. So this is a negative parabola. It's going to be frowning, opens upside down. And then this is hopefully recognizes in vertex form, opposite same. So opposite of this value would be -1, and then the same as your k value is -2. I'm going to plot my vertex at -1, -2. I know it's going to open downward. So what did I say you need to do? You need to find one other point at least. And you can toss this in the graphing calculator if that's quicker. But I'm going to go 1 point to the right, in other words. So I already have my vertex as -1, -2. 1 point to the right would be 0. If I plug in 0 into my function, I will get I get 0 plus 1 would be 1. 1 squared is 1. So I would have -1 minus 2, that's -3. So 0, -3. So here would be my axis of symmetry through my vertex, which would be x equals -1. By symmetry, if I have 1 point to the right, I got 1 point to the left. So my parabola will look like this. Okay, so let's list these different things. Here's my axis of symmetry. Now, my x-intercepts, well, I'm going to say that they do not exist. Now, I got to be careful. They do not exist in the real number system. We would have complex numbers, but for purposes of graphing, I'm just saying they do not exist. Domain, all real numbers. Range would be y is less than or equal to -2. Hopefully you recognize that this one is also in vertex form. This would be like 2 times x plus 0 times x minus 1. So what are my zeros or my x-intercepts? It would be 0 and +1. So 0, 0, and 1, 0. Let's find my vertex. It's going to be halfway between those two. So if I add 0 plus 1, chop it in half, it's going to occur at 1/2 comma something. So I'm going to plug 1/2 into my function to find what that something is. And I get -1/2. So 1/2 comma -1/2 is right here. And I already said my parabola is going to open upward, so my parabola looks like this. So domain is all real numbers. Range would be y is greater than or equal to -1/2, the y value of the vertex. Axis of symmetry, I need to list that, would be the vertical line. It's kind of sloppy, but through the vertex, x equals 1/2. If you're asked to find the y-intercept, it's right there. It's also 0, 0. Okay, your turn to do this one. Press pause, hit play when you're ready to check your answer. Okay, so this one is in vertex form. So my vertex, opposite same, would be 1, 0. I'm going to go ahead and plot that on the x-axis. So my axis of symmetry is the vertical line through my vertex. It's going to be x equals 1. I'm going to find one point to the right. I know this is going to be a smiley face that opens upward. So I'm going to find one value to the right, so I'm going to plug in 2. So if I plug in 2 for my x, my y would be 1/2 times 2 minus 1 squared, which would be 1/2. So 2 1/2 is right here. So by symmetry, I know I have to have one right here at 0 1/2. And I'm going to sketch my parabola, making it as symmetrical as possible. My x-intercepts, well, can use the graphing calculator, but I don't need to for this one because look, it's sitting right on the x-axis. It's the same as my vertex this time. It's 1, 0. My domain is all real numbers, and my range is y is greater than or equal to 0.